In this video, we will examine the characteristics of the DE726 test and measurement horn. The measurement data for this horn is located in your advanced data directory in the file named DE700_26.dat. Next, we'll begin examining the data by first using the simulator monitoring plot. We will recall Reg4, which contains the associated gain of the horn. Recalling this dataset will establish it as our active data, which will be located in Reg0. In the simulator monitoring plot, if we invoke the maximum, it will automatically move the azimuth sliders to 0, 0. If the plot is then rescaled from 0 to 20 dB, we can begin to see the results in the gain profile. Right-clicking reveals a menu of options. In this case, we want to invoke the markers to enable a detailed examination of this graph. We can see that at 26 GHz our horn's gain is typically 18 dB. At 700 MHz, the gain is typically 4.1 dB. The gain can also be viewed in the AS-L3D viewer, which we will do momentarily. The measured reflection data is stored in Reg3, which we will load and examine next. I'm going to extend the plot down to -25 and recall the reflection data while maintaining the gain data. Now what we have is gain and match data for the horn as well as the associated phase of the reflection. We can view the gain contours in the AS-L data viewer by specifying the AS-L and moving the frequency slider to the appropriate location. Now I'm also going to hold all the plots. Then I'm also going to plot the contours from -3 to -6 to -10. As a result, we have a very circular 700 MHz gain profile with a beam width of about 70 degrees. If we examine the midband at 12 GHz, it's evident that the beam width is smaller but still has a very good 3 dB profile. If we go all the way to 26 GHz, the beam width becomes very narrow and the 10 dB contours at 26 GHz are somewhat broken up. We can further examine this data in the polar plot. Within the polar plot, going to the max and selecting Keep will display all of the profiles throughout the entire frequency range. What this allows us to do is to slide the slider and examine all of the beam width profiles normalized to the unity circle. In this case, we see 700 MHz with a beam width of 74 degrees, and as we slide the slider up, we can see the beam width becomes consistently narrower. As you can see, the careful design of the DE horn has eliminated the typical problem known as flowering. And this concludes our examination of the DE726 test and measurement horn. Should you have any questions about the performance of this horn, please give us a call or email us. We hope this video was informative and helpful. Thanks for watching and have a great day.